Okay, guys. So when I watched the video, Nabonba, I did a lot of mistakes, especially when it comes to like the value of A. So it works like this. So when our graph is positive above the x-axis, all the values of A that are bigger than 1 make our graph, compresses our graph. And all the values of A between 0 and 1 make our graph, scratches our graph, okay? Then when A is negative, feel me? That means our graph is below the x-axis. What happens? All the values of A that are less than -1 compresses our graph, and all the values that are between 0 and -1 scratches our graph. Now, back to the video. So that's it. Okay, that is said. I'm not a tutor. Boom. Now, what are we doing right now? So this video is gonna be about math. The next one is gonna be about life sciences. Remember I said what I want is to make the best. I'm left with 9 videos to post. So I have to make the best life sciences and mathematics content. The best 9 videos of life sciences and mathematics I can possibly do. Feel me? I'll give you my all. So yeah, just tune out, just watch out for that. Anyway, so that's the first thing said. 1, I'm not a tutor. Second, how important or what is my strategy of going about doing this content. And so without further ado, the first video is actually going to be about what I'm actually doing right now. So remember, just bear with me, right? The first few videos are going to be awkward as fuck because I'm like, what am I fucking doing? Like, what am I fucking doing, bro? Like, honestly, bro. Like, honestly. Anyway, let's go show you something. So, you guys are gonna be seeing a lot of this right here. What I'm saying, because bro, I've always had a dream, bro. It's still my dream of like having a big whiteboard at the back and just like talking about like this type of content, but just not many other stuff, but like some crazy content. So yeah, you guys are gonna see a lot of these. So yeah, I'm excited, bro. I'm excited. Yeah, and obviously because if I'm doing mathematics, you'll be seeing a lot of this. You feel what I'm saying? Let's go. So what am I doing right now? So what am I doing right now? I am doing functions. Right now I'm doing functions. Specifically, I'm doing exponential graphs. You know what I'm saying? I'm doing exponential graph. The great part is that I'm writing next week. I'm writing next week. And here I am telling you about this content, bro. And what I'll say this, but it has been like it has been like trying to like study mathematics, study life sciences, and also studying my modules has been like the most difficult thing ever. Anyway, bro, let's go. So today is the 18th of April 2096. 18th April 2096. Feel what I'm saying? I'll make a thumbnail. Okay, this is probably the most awkward and weird 3 seconds of my life. I'm gonna do some thumbnails for me. Trust me, bro. Anyway, so doing exponential functions, and now I'm thinking, what exponential function is the most difficult in like grade 12? No, I don't think so. No, they're definitely not the most difficult. They were the most tricky. I would say this. In like my high school career, I didn't like have I didn't like have this mentality of like covering all the theory or covering all the work to understand everything about the exponential graphs and then going about like writing the exam or test of that of whatever the subject. For me, I just had the idea of like whatever I did in class, just understand that and then just go right with my understanding of whatever I did in class. So there was no, like, my entire school career, there was no me like taking out my textbook and saying, okay, in exponential functions, there's this subheading, this subheading, this subheading, this subheading. You feel what I'm saying? I just go with whatever the teacher had on the board, and I think that was my mistake. So this is advice right here, but like Dennis advice. So if you in matric or if you in high school, like grade 10, you should like use a textbook, go to a textbook, and I think I have some, I'll show you right now. So let's say for example you're in grade 10, I don't know, I have a grade 10 textbook, but feel me? It's a grade 10 textbook right here. It's a mathematics, caps textbook. So if we have a grade 10 textbook like this, if you know what I'm saying, what you do to the textbook, you usually wouldn't have a textbook like this in grade 10. This one is just, I don't know, probably stole this. I don't remember where, bro. Don't ask me, bro. Anyway, what you want to do, bro, you would want to go to the table of contents. You want to go here. You feel what I'm saying? You want to go here. And then if on that particular week or month, you'll be like doing numbers and number patterns. If you're doing numbers and number patterns, what you have to understand is that you have to understand all of these subheadings under numbers and number patterns. That's something I didn't do, bro. You feel like so I'm saying to you, bro, that's what you should do. So that means if you understand types of numbers, you understand rational and irrational numbers, you understand inverses, intervals on the number line, you understand that, and you understand all of the thirds and number patterns, then you can then say, well, oh, then I understand numbers and number patterns like that, and just that's how you go about it. You just do that. Something I didn't do, which was crazy. Anyway, I'll be honest, but I'm obsessed right now. I'm like, what's going on? What point am I trying to prove? I don't know what point I'm trying to prove. Anyway, the standard form. The standard form of exponential graph is as follows. Bear with me when I see right now. F of x is equal to a, b, is b. Feel me? So yeah, it's like this. This is the standard form of the exponential graph. F of x goes like this. So f of x is equal to a times b to the power of x plus p plus q. So right, the first thing with exponential graph is understanding parentheses. Bro, I can already tell, bro. So the relationship between me and the audience right here, when I thought about it, was like, okay, well, I'm not tutoring, you feel what I'm saying, but I'm trying to like teach this because I remember I learned about the studying or learning pyramid, where like if you read in order to understand your notes, then you gotta like retain like less information. Like learning should be about retaining the information. It's crazy that I'm saying all this, but it's actually not working. Okay, well, that's a lie. That's a lie. I should rephrase. I want to say it's crazy that I know this, but I'm actually not using it when I'm studying my modules. That's crazy. Am I not using it? I'm trying to think now. What is the last thing I did when I was studying my module? It was I watched a YouTube video. So that's I didn't do the diagrams myself, and then also use flashcards. But anyway, you see, I think I'm not using this as much as I possibly can. So that's not right. I should use it more. Anyway, what was I gonna say? Oh, parentheses. The first thing is standard form. The second thing you should understand are parentheses. How do you write parentheses? The C's are parentheses. So if you guys cannot see, bro, sorry, bro. So anyway, parentheses. So parentheses, what you have to understand about parentheses is that A makes the graph steeper. Right? This is not steep, it's steep. So A makes the function of graph steep, not sleep, steep, if you know what I'm saying. So let's say we have a positive graph right here. Oh my god, why did I write it like this? I don't want to use this because it's just going to be dirty. So I'll use toilet paper instead. So you dance from the corner, cause your name. So if we have a function right here, an increasing function like this, you feel me? So if we have an increasing function, the values of A makes the function steep. But now, I actually don't know what values of A makes it steep, so I'm gonna just find out right now. So, steep means this, like how close is the function next to the y-axis? How close is the function to the y-axis? Do you guys understand that? That's what steep means. So now let's check. What values of A makes our graph steep? Let's say, so I'll say I'll use all the values of A bigger than 0, and then I'll use all the values of A that are between 0 and 1. Okay, and I'll talk about why I'm using those values in a little bit. So let's say f of x was given by the equation 2 times, I don't know, 2x. For now, let's not use parentheses, or anyway, let's use them. Let's say p was 0 and then q was also 0, so you guys can see that we have a function just like this. You feel me? So let's say we have, for example, okay, I should stop touching it there. Let's say, for example, we have a function where a is 2, right? B is also 2. P is 0 and Q is 0, so we have a function like this. Okay. Now we want to see which values of x of A makes our function steep. Let's just check. So what is the value of y when x is 1? So the value of y is 4. Okay. So you dance. So that's 1 is here, 4 is probably there. Okay, this is not drawn to scale, guys, no? Like this. Now we then use this point in order to see. So we go bigger, we go like. So now we have a point when x is 1. This is so delicate. It's crazy. So you touch it once, it just goes away. So, what if my phone is shut? Oh, it is not. Anyway, parentheses. What you then do? Let's check that. So if x is 1, okay. Shit is taking a lot of time, guys. I actually don't want to use those values. So you don't. If x is 1, what happens? Okay, I'm trying to draw something so you guys can see. Okay, I'll do like this. So if x is 1, y is equal to 4. Then let's see. So this is the case. So now we make a bigger. So let's say a. Now we're gonna say, okay, what if a was, I'm just thinking about this now. You see, I should probably prepare for this part. If a is equal to, what happens to, what is the value of y when a is equal to 3? So we see we're going bigger. I say let's say 4 instead. So we all the values of a just bigger than 0, 4, and x is 1 and y. I'm sorry, what is y? Let's see. So what is y? What is y when x is 1 and a is 4? Let's see. Is it going to be steeper or is it going to be less steep? What we're trying to find here is what values of a makes our function steeper. Okay, let's say 4. So we're going to say 4 instead of the 2, we're going to substitute the 4. So here, so just here, instead of the 2, we're going to substitute the 4. You know what I'm saying? So 4 times 2 times 2 to the power of, we said x was 1 to the power of 1. That's 8. So our graph is steeper. You know what I'm saying? So there we go. There. We can then see. So I don't know what will happen with the other side. Play hard to. Okay. We can see that the function. So all the values of, so it becomes 8. I'll show you now. So there, it becomes 8. It becomes 8. If a is 4, x is 1, our y value becomes 8, making our function steeper. You feel me? So all the values of a just bigger than 1 makes the function more steeper. We said steeper. We see we measure steepness according to, we see steepness according to how the function, how close is the function to the y-axis. You know what I'm saying? So because 8 makes it closer, you can see this function, the red one, is closer to the y-axis than this one, the black one. Meaning the function is steeper and the values of y increase. Feel me? And now let's check, what if a is a half? Feel me? I'm assuming it's gonna be like less, more or less steep. What does that work? Anyway. So what happens? So then we're gonna do the same thing. Substitute a half here times 2, you put 1 here. You know what I'm saying? That's how I'm finding these things. So that's how I'm finding. So 2 a half, times 2 to the power of 1. Our graph is 1. You can see that's that is like, okay, I don't have another color, so I'm just gonna use red. You know what I'm saying? So when x is 1, y is 1 also. So you can see that's like, whoa, shit. That is the steep. Feel me? So you turns even like goes but then so look at the second red line. So if you guys look at the second red line, this one, the second red line with the coordinates 1 and 1, you can see it's like more, it's less steeper. You feel what I'm saying? It's less steep. So it's less steeper than the two functions, and so we know how the a parenthesis works. So it makes the graph steeper with all the values of guys. This is like so delicate. When I touch it, it just erases. So sorry. I don't know what the fuck. Man. This is so delicate. Food. I touch it. Gets fucked up. Nonetheless, but there we go, bro. So that's what happens for parentheses, and I'm assuming as you go deeper, so that's what happens. The bigger values of a makes the function steeper. So for all values of a just greater than 0, all functions greater than 0 makes the function steeper. So the more you increase the values of x, the steeper the graph becomes. And the more you decrease the values of a, the less steeper the graph becomes. Now what's very interesting is what happens when our function, our a is negative. Will that do? Then we have a decreasing graph, isn't it? How am I trying to shit you? Cut it -4. We definitely have a decreasing graph. We have a graph that looks completely different. If a is negative, we have a graph that is, I don't know if increasing, like from the third quadrant, and it goes like this. A graph that is completely under, you feel what I'm saying, under the x-axis. That's what I think. Because yeah, if we substitute a is equal to -4 and x is 0, I don't know why I'm showing this. You definitely don't see this. Feel me? Our graph cuts the y-axis at -4, so cuts the graph in -4. This is 1. No. It's actually decreasing. So when it's decreasing like this, if you want to know. So if you wondered, okay, now, Sinalo, I hear what you're saying. I hear what you're saying. So when a is negative, right? This is for positive values. When A is negative, I'm not going to write this down, I'm just going to finish it. When A is negative, our graph is under the x-axis. If you know what I'm saying, it's under the x-axis. This is the x-axis there. Yeah? And it decreases. So it goes to like more low values of what is this? Say something. Of y. Then I think the same thing applies, bro. I don't know, bro, but I think the same thing applies when A is just between, like, goes like from when A becomes more values of, like, as A is like bigger than negative, like is less than 0, the graph becomes more steeper. That's what I think. Yeah. Let's say A was 8, our graph would be 16. It's the same thing. So we can then say, so now I'm gonna like synthesize very quickly, if you. So I'm just gonna erase everything. So okay, I'm just gonna explain first. So it's the same thing. Aniti, we said, when our graph is positive, like above the x-axis, values of A just bigger than 0 makes the graph steep. Values of A that are between 0 and -1 makes the graph even less steeper. The graph less steeper. So steeper when values are bigger than 0, less steeper, open, when the graphs are just between 0 and 1. You mean? So now when the graph is negative, when the function is negative, not decreasing, negative meaning below the x-axis, values of A that are just lesser than 0, just like -8, -60, -7, -9, -10, you go that way, the graph becomes steep, right? When values are between 0 and -1, then our graph becomes less and less steep. Feel me? And then if you continue going this way, like between, like, you continue going from like -2, -1, 0, then 1, our graph is gonna then be on the top 2 quadrants. Anyway, so that's what we see. So if I synthesize this quickly, feel me? If I synthesize this quickly, synthesis. So there we go. So these are our synthesis. Feel me? Right. So when A is negative, no. I'm mistaken. My bad. So when A is positive, all the values of A that are bigger than 0 makes the graph steep, makes the exponential graph steep. And then all the values that are between 0 and 1 makes the graph less steep, right? As you use like fractions, the graph becomes less steep. It becomes more open or further from the y-axis. When our a is negative, we said our graph is going to be below the x-axis, either going like this or going like this. See me? Nonetheless, when a is less than 0, like all the values of a, like just greater than 0, we say like 1, 2, like for in this restriction, I'm using all like whole numbers, you feel what I'm saying? Just think of like whole numbers. Okay, that's what I'm thinking of, but I don't know. For me, I'm thinking of like whole numbers, like 1, -1, -1, -2, -3, -4, -5, -6, and so on. Our graph becomes steep. However, when you start using functions, fractions, then our graph becomes less steep, like -1/2, -1/3, -1/4, like. Then when you use like stuff like that, our graph becomes less steep. So that is the first parenthesis. You feel me? First parenthesis. And yeah, that was a lot to digest, bro.